Now, just so you understand, on the assessment, it's going to ask you to solve quadratics algebraically. That means you have to show us either by factoring, by square roots, or by quadratic formula. We are not going to tell you you have to show us by factoring. We're not going to tell you you have to show us by quadratic formula. We're not going to tell you you have to show us by square roots. Okay? But you have to show one of those three. You have to choose one of those three. Some of them, and that's what we're going to practice today, some of them are set up for factoring. Some of them are set up for square roots. Some of them are set up for quadratic formula. Okay? Some of those things are already set up. They're done more easily by one of the three methods than the other two. But that doesn't mean it has to be done that way. Square roots is the only one that, well, I shouldn't say that. Quadratic formula will always work no matter what the method is. It will always work. Okay? Square roots will only work for certain problems. And factoring, not everything factors into nice numbers, so factoring won't always work either. Okay? Now, you can always check them by using your graphing calculator. That's why I said you should have your graphing calculator, and one person came up and got it, but you might want to fix that as soon as we pause here. I will show you how to solve these on your graphing calculator so that you can check and know you have the right answer. Okay? But you have to demonstrate on paper, on the assessment, one of these three methods. Okay? It's a must. If you don't, you get zilch or almost zilch points for it. Okay? And then we're going to talk about imaginary numbers a little bit today. Okay, well, between today and tomorrow. All right? As they are needed, we'll throw them in. Okay? I'm going to pause and get your calculators. First of all, I want to remind you of how to factor. Okay? So if I just take this quadratic, x squared minus 2x minus 15. Okay. We want to factor that. If it's a quadratic, and there's three terms like this, the only way it can factor would be into two binomials. Binomial means two terms. Right, two terms. Okay? And I don't think you guys had me for Algebra 1, but had you had me for Algebra 1 when you were taught this, I would have said the way I like to do this is to set up things that have to be true. Okay? For example, the only way to get x squared is x times x. I mean, you could say x squared times 1, but you kind of already have x squared, right? If you had x squared times 1. So the only way to get that to be x squared is x times x. So these first two slots have to be x times x. Okay? The only way that sign could be negative is if these two signs are opposite. The only way I can get a negative is if I multiply a negative and a positive. Right? What's negative 2 times negative 2? Positive 4. What's 3 times 4? Positive 12. So the only way to get a negative would be like negative 2 times positive 3. What would that be? Negative 6. Okay? So the only way that can be a negative sign and get a negative 15 is if these two signs are opposite. One positive, one negative. And you might say, well, how do you know where it goes? And I say, I don't care. I'm just going to put it in. Okay? If this number here is anything other than a 1, then I'm probably not going to use this factoring method on it anyway. I shouldn't say that. I probably would, because I am really good at factoring. But I understand, because I was once you, how difficult factoring is to grasp. And some of you right now are saying, whoa, 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 where'd you get that? Okay? Hopefully we can work you through that, and you can accept that this is an easier way to solve some problems. Okay? But if it isn't for you, then maybe you never factor. That's why we're not telling you you have to do it this way. But we are all going to practice some problems like this. And after you practice it a few times, if it's just not the way that clicks for you, then fine, you don't have to use it again. Okay? Alright, so now we have to say, how can I get 15? Just like here we said, how did I get x squared? It was only x by x. Well, 15 could be 1 times 15 or 3 times 5. Do you agree? That's how I get 15, right? Okay, so now comes in this middle number. Because the signs are different, we're looking for the factors of 15 that subtract to give me 2. What are they? 3 and 5. The factors of 15 that subtract to give me 2. If I subtract 5 minus 3, I get 2. Okay? Now, it's not just a 2, it's a what? It's a negative 2. So that means I want my bigger number to be the negative 1. So I have slot 1, slot 2. Where should the 5 go? In slot 2. And the 3 goes then in slot 1. All right? I'm going to erase that 1 and 2 so it doesn't look like a fraction now. All right?
Board's running slow, isn't
A little bit. I probably have too much running down here. Let's get rid of this. So anyway, factoring. It works best when the number in front of the x squared is a 1. It's much easier to factor that way. It can be done other ways. We actually taught you a grouping method when it's not a 1 to use a grouping method. And I could remind you of that. Anybody that says, hey, I really like factoring, but I forgot that, and I want to look at it, I'll be glad to remind you. I'm not going to put the whole class through it, though. If I have this one, x squared minus 12x plus 32. I want to factor this one. Okay? I'll give you a moment to write that down. We are taking notes now. When I check your notebook, I'll expect to see all this stuff in your notebook. All right? Again, there are how many terms? 3. There's an x squared, a 12x, and a 32, right? 3 terms. So it's a trinomial. It's a quadratic because the highest degree is 2, right? X squared. And so the only way, if this factors, the only way it could factor would be 2 binomials. Okay? The only way would be 2 binomials. And that, again, that means we have to have 4 slots. Okay? All right. Abby, can you name one thing that has to be true if this factors? Okay? So can you tell me where? Let's just do this. I'm going to number this 1, 2, 3, 4. So, that's a 4, sorry. Oh my goodness. I don't think it's matched up with my finger very well.
It has to get worse before it gets better.
Yeah, well. There we go. So, now, can you tell me again where you want the x? In 1 and 3. The only way to get x squared is x times x. You're right, they have to go there. Okay? Can anybody tell me anything else that has to be true? Plus or minus? Dewey's behind you going. Why do you disagree, Dewey?
Because it has to multiply to get positive 32. So it must be negative.
So he's looking at this sign here saying, that's a positive. Remember that first one we circled that last sign? And we said it's a negative. The only way to get a negative was 1 plus 1 minus. But this time it's a positive. And so the only way to get positive is either negative times a negative or a positive times a positive, right? So which 2 should we use here?
Negative times negative.
Why?
Because, well, it's a negative.
Yeah, because that's a minus sign. The only way to get some negatives is if both of these signs are negatives. Okay? So when this is a positive, this one here is a positive, that means our 2 signs have to be the same. And they have to be the same as this. Okay? So in this case, they both have to be negatives. That makes life so much easier in the factoring world. Because now we're going to go to the factors of 32. 1 and 32. What else?
8 and 4.
2 and 16. 4 and 8. 5 doesn't, 6 doesn't, 7 doesn't, 8, yeah, we're back up to 8. If you go in order like this, 1 goes in there 32 times, 2 goes in there 16 times, 3 doesn't, 4 goes in there 8 times, then you heard me say 5, 6, 7, 8. Once I get to a number I already had, I'm done. None of those went, okay? So if you're listing all the factors, you can just write them down like that and list them. And now, what's special about these 2? Before we said they had to subtract to give me 2. Why did they have to subtract? Because the B or the signs were opposite, right? They were negatives. I'm really adding. I add a positive and a negative, and the rule for that is you take the smaller one from the bigger one, right? And keep the sign of the bigger number. So we're in adding 1 positive, 1 negative, we're really subtracting. But in this case, we're adding 2 negatives, which means we're really adding them. And so we're looking for the factors that add up to 12. 8 and 4. Okay? Where should I put the 4 at? In 4? Someone said it's up to me. You're right. I can put it wherever I want to put them because both signs are the same. So it doesn't matter where they go. Okay? Doesn't matter where they go. Any questions on this one? Anybody kind of foggy about this? I'm going to do one more. Anyone? Yeah.
Okay, so like what if, I'm a little confused, so
Okay.
if like the first set was a plus instead of minus?
So, you're saying what if I had x squared plus 7x plus 10?
And then like, because you said it doesn't matter where you put them.
Okay.
So if,
Well,
what makes it
why didn't it matter?
They're both the same.
Because the signs are the same, that's why it didn't matter. When the signs were different, it did matter though, right? Because I had to make that 5 negative, right?
Yeah.
Remember that? Okay, so help me with this one. 1, 2, 3, 4. We won't number them every time, you'll just understand 1, 2, 3, 4. We'll just go right across the screen. So, what has to be true? 1 and 3 are x's. Okay? Someone take the pressure off her. What else has to be true?
Both have to be positive.
Both what?
Both of the 2 numbers that you put in there.
Okay, so both signs, right, have to be plus. This tells me they have to be the same as this. And so Noah's saying they both have to be positives or plus signs. Okay? And then we get to the point where we have to know, well, what goes in there? Well, we take 10 and we find the factors. 1 times 10, 2 times 5, 3 doesn't go, 4 doesn't go, 5, we're back to where we started. So which 2, because the signs are the same, do what?
2 and 5 equals 7, so yeah, so the numbers you're
They
going to use.
have to add up to 7, right? And you said 2 and 5. And it doesn't matter where they go? No, because both signs are the same. It doesn't matter. If I want to go 2 here, 5 there, that's fine. If you want to go 5 here and 2 there, that's fine also. We get the same answer. Okay? This is why. What is 2 times 3? 6. What is 3 times 2? Didn't matter which way I wrote them, did it? I still get 6.
So that's all you have to do.
And this is a number times a number. So it doesn't matter if these are flipped around. I'm still going to have the same answer. Okay? Now, you started to ask something. I was still talking.
Sorry,
Did you answer it yourself?
I'm assuming that's all you have to do, like, that's your answer.
Yeah, that's the answer. That's all you have to do. Okay, let me give you, we'll go 3 problems are in the book. Pause a second. Yeah, actually there aren't any problems yet. We haven't actually accomplished what we need to. Okay? This was to remind you how to factor. Alright? So now this is what the problem's going to look like in the book. 0 equal, well, let's go the other way. Let's put 0 on the other side. X minus x squared, sorry, minus 5x plus 6 equals 0. Thank you. Okay? X minus 5x plus 6 equals 0.
We're doing this for
No, I'm going to walk you through this. What we hadn't talked about yet is the little rule that says a times b equals 0. Should have said if a times b equals 0, then a equals 0 or b equals 0. Well, this is not responding very well today. I have to write slower than it keeps up with me. Okay? That's a rule you learned a long time ago, at least in algebra, if not before. So if you know 5 times something equals 0, then that something has to be what? 0. Right? The only way to multiply 2 numbers together and get 0 is if one of those 2 numbers is equal to 0. So what we want to do to solve this then is we're going to factor this so that we have this type of scenario. Right? If we look back at these factors, A times B, A times B, A times B. Okay? By factoring, we put them in that scenario where it looks like it's 2 numbers being multiplied together. So how do I factor? How do I factor this? What has to be true? X's go in, 1 in, 3. What else has to be true?
Plus, minus, plus, minus.
Both signs are negative, aren't they? Because this is a positive, both signs have to match this one. And so they're both negative, both minus. And now the factors of 6. 1 times 6, 2 times 3. Because the signs are the same, what do I do with my factors to get that middle number? Add them. Which 2 add up to 5? 2 and 3. See, this could be easily confused if you put one of each. 6 minus 1 equals 5 too, doesn't it? But then if you tested it, you wouldn't get back to a positive 6. When I say tested, I mean you can always FOIL this back out, and you should get back to where you started. Okay? You can always FOIL your answer back out, and you should be able to get back where you started. And so if you had done this one wrong, and grabbed 1 and 6, and you FOILed it back out, you wouldn't get back to what we started with up here. Okay, so factors are 2 and 3. Doesn't matter where they go, because signs are the same. And now I'm applying this rule right here. X minus 2, didn't really need the parentheses, is equal to 0, or x minus 3 is equal to 0. No, almost. So if x minus 2 equals 0, what's x equal? Positive 2. Remember, add 2 to both sides? If x minus 3 is equal to 0, what's x equal? Positive 3. Oh my goodness, this is annoying. So those are my answers. Okay? Now they might write it in set brace form like this and say 2 comma 3. Okay? That's not an ordered pair, those are set braces. I mean, if it looked like this, it would be an ordered pair, and that's not true because they're both x values, right? But if they write it this way, just so you understand, it's the same thing as I boxed in up there. Okay? Any questions on how to take those factors and solve for 0? All right. In that case, let me pause a second. I'll give. Now try number 36 and 48 on page what? 267. That was solving by, whoops, let me go back. I didn't record the answers. So the answers were right there. Now moving on, solving by square roots. X squared equals 4. Okay? X squared equals 4. The most basic square root problem we could have. X squared equals 4. So how do we undo an x squared? We square root both sides. And square root of x squared is x. And square root of 4 is 2. Unfortunately, 2 is not the only answer. Because 2 is not the only number that I can multiply by itself and get 4. Yes, a negative 2 and a positive 2 both could be multiplied together to give me 4. And so anytime you square root both sides, you have to understand you're going to get a positive and a negative answer. Okay? A positive and a negative answer. So if I had this problem, 9x squared minus 16 equals 0. Well, I could factor that if I wanted to. I could, because isn't 9 3 squared? And x squared is x squared. And 16 is 4 squared. And that sign between them is a minus, so I really have the difference of 2 squares here. So I could factor it. But this problem is done much more easily by using square roots. So to use square roots, what we want to do is get the x squared all by itself, like we had here in the first place. So what do I do with the minus 16 to get the x squared all by itself? Add 16. So I get 9x squared equals 0 plus 16, which is 16. I still don't have the x squared all by itself, do I? So what do I do now? Divide by 9. Now I recommend to you that you not try to make that a mixed number. Okay? Now if I had 32 over 18 and they're both even, I might take a 2 out of both of them first before I went further. But in this case, they're both perfect squares, aren't they? 16 is 4 squared, and 9 is 3 squared. So they're both perfect squares. So now I'm ready now to take the square root of both sides. Remember, when you do that, you have to get a plus and a minus. So a plus and a minus. What's square root of 16? 4. What's the square root of 9? So my answer is x equals a plus or minus 4/3. That means I have two answers there. One number is a positive 4/3, another number is a negative 4/3. Yeah, it is. Another very, very simple concept. Things you've done before probably, but not necessarily in this context. Okay? All right, so let me pause for a second. Let's do one more example. do a problem like this. X minus 2 squared equals 16. Okay? Now, I want you to not write for a minute. I'd like you to just set your pencil down and watch me, because I'm going to do a little substitution to make sure you understand the concept that's happening here. And then I'll erase it and we'll just go straight to the problem, okay? But what's really happening here is this could be treated like an A. All of this number here, which, you know, sometimes it's a mess. In this case, it's not too bad, but there's two terms to it. So it's not as simple as A. But I could treat this like A squared equals 16. And then what would I do? I would square root both sides. And I would not forget, I get plus to minus, so what would A equal?
4.
Plus or minus 4, meaning positive or negative 4. Okay? That's all I'm doing. That's the concept. All right? Now it looks a little different because there's more than one term there. So this number's already squared. So now you can pick your pencil up again. I'm going to undo that squared by square rooting. The key is all of this is being squared. If I had other numbers over here, then it's not ready to be square rooted yet. But all of this side is being squared by 2. Or being squared, I should say. So we square root both sides. And so all of this, when I square root all of this, my square root and my square cancel, I'm left with x minus 2 equal to
4.
positive or negative 4. Okay? Now, do I have the x all by itself? So I'm going to add 2 to both sides. And now listen, whenever you do this, whenever you add to both sides to a plus or minus, put whatever you're adding or subtracting first. And so I'm going to write this number first. So 2 plus or minus 4. Now I'm so far picked all nice numbers that have worked out well. Sometimes they're not, and I'm going to show you some of those in a minute. Okay? But right now we've picked all nice numbers that have all worked out. There's 2 answers here. Can someone tell me how I get the first answer? 2 plus 4. How do I get the second answer? 2 minus 4. And so what is 2 plus 4? And 2 minus 4? And so my answers are
5, 6, 6, 0.
okay? And another way you can write your answer, I'm very happy with that also. You're just making a list. Not putting it in the set braces, you're just making a list. That's okay also. These are all the values that x could be. Okay? Any questions on that one? All right. I'm going to give you one more. The answer is not going to be as nice. At least I'm not going to make sure it's nice. I hope it doesn't work out. We're going to say 2x squared minus 5 equals 12. Yeah, we know it's not going to work out nice now. Okay? So what should I do first? Alyssa, you help us out first.
Are we going to square root it?
Well, yeah, oh, you know, here's a good question. How do I know this is a square root problem?
Because there's this.
There's a number.
There's an x squared, but there's no x term, is there?
No.
B in ax squared plus bx plus c, b must be 0 because there's no x term. If there's no x term, then it's a perfect candidate to solve by square roots. Okay? I forgot to mention that before. I'm glad we got it covered. All right? So now, we're going to solve this by square roots. What was the goal to solve by square roots? What do I have to get all by itself?
The x squared.
The x squared, or the quantity squared, right? And so what do I do first, Alyssa, to get the x squared all by itself?
Add 5.
Add 5. You guys are algebra 2 students. If you want to show the plus 5 on both sides, go ahead. If not, just rewrite that as 2x squared equals 17. What do I do next?
Divide by 2.
Divide by 2. And so I get x squared equals 17 halves. Ugly number. Ugly. Almost as bad as when I look in the mirror. It is that ugly. Okay? Now, we got the x squared all by itself. So now we're going to square root both sides. Okay? And we're going to get an x over here. And on this side, we're going to get a plus or minus square root of 17 halves. Now, the reality is, most of the time they do not allow you to leave this in the denominator. Remember in algebra and geometry, we reminded you how to rationalize the denominator. For now, we're just going to leave it that way. Okay? For now, we're just going to leave it like that. We're not going to worry about the fact we have a denominator inside our radical sign. Okay? Square root, cube root, fourth root, those are all called radical signs. Okay? So we're not going to worry about that. All right? Any questions on this? What can I forget when I report that answer? The square root. What else can I forget? The plus or minus. You leave that off, you're only giving me one answer, and that's wrong. Okay? All right. I said only one more, but I lied. We got to do one more. X plus 5 squared equals, let's just say 7. Yeah, I'm good with that. That's kind of, I started to think bigger numbers and I thought, no, we'll go smaller, and you shouted out 7 is. Literally, as I'm thinking of non-perfect square numbers, so good.
Good job.
So what do we do? The term squared, the quantity squared is already by itself, isn't it? If it wasn't, we'd move everything over. If there's a plus something here and a number out here, we'd move the 6 over, we'd divide by 3, we'd do all that. Okay? In this case, it's already all by itself. So what do? Square root both sides. What do I get on the left side? X plus 5. What do I get on the right side?
Square root 7.
Plus or minus square root of 7. I'm still hearing people shout it out without the plus or minus. Can't forget it. Okay? You can't have the attitude, oh, I just forgot, it's not a big deal. It is a big deal. You're only reporting half the answers, your answer's wrong. Okay? You have to have it in there. Now, what do? Get rid of the 5. Minus 5. And so we get x equals, what did I tell you, where to tell you to write that?
First.
First. Always write it first. Okay? The reason we always write it first is because sometimes that plus or minus, what follows is not a nice number. Like in this case, square root of 7, not a nice number. It's irrational. Okay? Like you think I am some days. Alright? So, it's important that you understand that you need to write it this way, and this is the way we'll leave the answer. If they ask you to round to the nearest tenth, then you would say, okay, I have negative 5 plus square root of 7, and I have a negative 5 minus square root of 7. And if we rounded that off, try it on your calculator. What do you get if you type in negative 5 plus square root of 7? This half of the room, negative 5 plus square root of 7. That half of the room, negative 5 minus square root of 7. Negative 2 point, we're rounding to the 10th. 2 point what? 4?
Negative 7.6.
Negative 7.6. Okay? If they ask you to round, that's where you would do it at the end, just like that. Notice it's not just a plus or minus negative 2.4, is it?
Right.
You have to break this up and actually do it two different ways. One with a minus, one with a plus. Because that's what this means. Okay?
Oh, because you didn't add it.
The top one is negative 5 plus square root of 7. The bottom is negative 5 minus square root of 7. Anybody disagree with those answers?
No.
Any questions on them?
No.
All right. Let me pause for a second. I'll tell you which. So we're trying now 43 and 51 on the same page, 267.